This is 2023 question number 9A. Let us try to look into this question. So you are given this function and it is asking you for what values of x1 and x2 is this function quasi-concave, right? So let us try to go ahead and see this question. So what you will be doing in this case, let us start by differentiating this with respect to x. So x1, so you will get x2 square. Let us differentiate this again with respect to x, so you will get 0. Let us differentiate this with respect to x2, so you will get 2x1, x2. And let us differentiate this again with respect to x2, so you will get 2x1. Right? Let us differentiate this with respect to x1, so you will get 2x2. Right? Let us try to go ahead and make a bordered Hessian matrix out of it. So if I formulate a bordered Hessian, I will go ahead and I will get 0, f1 dash, f2 dash, f1 dash, f2 dash. Here I will be having f11, f12, f21, f22. If I just go ahead and put these values, I will get 0. So first order differentiation was x2 square. So I will get x2 square, 2x1, x2, x2 square, 0, 2x2. And here I will be getting 2x1, x2. And 2x2 and 2x1. Let us try to go ahead and find the determinant of this matrix. So determinant will be 0. 0 minus 4x2 square, right? Minus x2 square, 2x1, x2 square, minus 4x1, x2 square, plus 2x1, x2, 2x2 cube minus 0. This will give me minus 2x1, x2 to the power 4 plus 4x1, x2 to the power 4 plus 4x1, x2 to the power 4. So 8 minus 2, 6x1, x2 to the power 4. Now it is quasi-concave if your Hessian matrix determinant is greater than 0. So 6x1, x2 to the power 4 is greater than 0. 6 is always already positive. Anything to the even power is already positive. So this is possible only as long as x1 is greater than 0. So it will be quasi-concave if x1 is greater than 0.